Hey, my name is David Wetmore, and I'm going to show off today Base Command Manager from NVIDIA. This is a cluster orchestration tool used for provisioning of operating systems, management of switchgear and network interface cards, Kubernetes clusters. Um, my team and I have been using this tool to deploy our Kubernetes clusters where we do our generative AI development, where we're creating products and service offerings for Lenovo. So I just thought that this is a tool that from the NVIDIA side has really been the backbone of the infrastructure that we really bring and deploy as part of our service offering. So just want to show off like what it is, what it does, why it might provide value to you, and maybe what are some other tools that are positioned that do something similar. So just here, looking at the cluster that we have deployed, this is got actually 3 GPU nodes with 8 H100 GPUs in them currently, and I'll go into some of that. Initially, when we deployed this cluster, it actually had 4 nodes. We've actually been able to easily remove and add and change and continue the development of this cluster dynamically, as opposed to maybe having to recreate the cluster on the fly. And Base Command Manager makes that pretty easy. So just obviously some graphs, some good utilization metrics for you here. Nothing, from my standpoint, from a managed services standpoint, this is what I would expect, to be given to your IT support community for them to be able to log in and view, identify maybe any challenges or moments of latency or throughput or peak utilization windows and things like that to help us further troubleshoot and log issues. Another thing that Base Command Manager can do is it can help you with your networks and your networking. So as part of what we bring on top of Base Command Manager, we bring Kubernetes. So you see a couple of these networks that are specific to the Kubernetes cluster, and then you see some of the networks that are created to actually do the deployment of the cluster itself at the operating system level. Um, Furthermore, you can manage your switchgear here. You can see that in our cluster we have a 2410 switch. That's a NVIDIA Mellanox switch, as well as a 4600 switch, another NVIDIA Mellanox Spectrum switch, high-speed switch here. Just showing you that they're up, they're managed. These actually, I could be more granular with the management of these. I've chose to just do my deployment of Cumulus Linux on those switches and configure that via Ansible automation or manually based off of my needs. But you can see you can do DHCP leases and reservations that way. Getting into provisioning, this is gonna be where your default image that's used to provision your compute nodes is used. So this is very common across any kind of tool used for cluster orchestration management. So you store this image, or maybe you have a hardened image that you want to use in your compute nodes. This is where you would upload, store that, and then specify that you want that to be used on your compute nodes. Groupings are used as a subset of groupings. You have categories, kind of synonymous in the words themselves, but a category gives you the ability to say, if I have a server that's in this specific configuration, it has this certain GPU type, and it has a certain storage profile, I can make a category specific to that deployment, and once that category is selected, it will be inherited that these are the storage configurations, this is a GPU configuration, so on and so forth for that category. So it just helps quicken your deployment and just feeding into the nature of the cluster orchestration tool that it is. Same thing with the node groups. It just gives you another ability to be able to organize your compute nodes in a way that when this is obviously a relatively small cluster, but as you scale this and there's hundreds, if not thousands of nodes or multi-thousands of nodes, having these groups and segmented in a novel fashion may help the sysadmin be able to manage this from a single source of truth that BCM really tries to position itself to be. Jumping down into the left into the devices, we already kind of saw my switch gear here. The coloring here can kind of be alarming. It's really just showing you one's pingable and one isn't a pingable interface, but they're all up. Nonetheless, this is my head node, and these are my two compute nodes. These are the switch gear that we're using in this stack. And we're just showing you the MAC addresses of those nodes from there. So if you wanted to drill down maybe into the head node specifically, you could see, you know, those specific things, interfaces, that sort of information specific to the head node, the disk, the mount points, routes introduced, that sort of thing. You can make your changes to the Pixie booting and the default gateway BIOS setup, that sort of thing here. Provisioning interfaces, that sort of thing. Jumping over to a compute node, we'll just, you know, we actually had removed node 001, that's why we're jumping into node 002, but you can see here we actually have 8 GPUs. There's no jobs running at this time. You can see, you know, all your utilizations, interfaces, tunnels, disk, mount points. Same thing. Settings. I think what's important to showcase here is that we do go ahead and select a category that we've created previously for AI compute, where it inherits things like the storage profile for this specific node. So the hard drives installed, we've already done a mapping for those hard drives and how we would like them to be configured. So we tie that to the category, and it inherits this from the category. From a provisioning standpoint, installation standpoint, you can tell the compute node whether you want to do a full install or some semblance of a partial install. These are your selections here. You can skip this altogether. You can read about all of these individual install modes on the NVIDIA documentation for BCM. Here's the disk setup that it inherited. This is specific to this node type that we have. And you could further this setup, right, and really customize this as closely to your needs as you can get. You can control the power if you set up your IPMI connection, and can talk to your baseboard management controller or like alternative. And then here you can see that it's talking about what the kernel version of the default image is, how you would like the bootloader to be TFTP or HTTP or some other thing, in categories, so on and so forth. So I was trying to see, I think it's in, yeah, so the software image ends up becoming probably the most important bit of information in my opinion when you're talking about the provisioning of the compute node. So the head node that you can see here is where we have Base Command Manager running and installed. We're trying to tell the head node, hey, I want you to provision this compute node with this default image. So inheriting from the AI compute category, the default image that's selected that I showed previously, it deploys the default image to these compute nodes. And that's what's happened. So you could, you know, in our case, it's actually the same image that's used across all three. You could have these be hardened images, FIPS compliant, whatever, you know, meets your fancy on that side. But that's kind of how the cluster is built at an OS level, right? So once the cluster is built at this level, there's so many other things that we can add and do power PDUs and rack sensors and chassis, and you can really use this tool as a single source of truth. You know, if that's how you want to leverage it. But I just wanted to show how you can simply make a cluster at the OS level with Base Command Manager, and then on top of that, be able to deploy something like Kubernetes. And that's really what my team specializes in, is to be able to bring those GPU advanced services, which includes the likes of Kubernetes and the operators that run on top, and ultimately the language models in the form of NVIDIA microservices or NIMs that we run on top of the Kubernetes containerization platform. So just simply want to show that off here. If we can see, there was a cluster created on a Kubernetes cluster created on this hardware cluster that we have created by BCM. we can drill down into that AI cluster that was created. And just from the GUI that we have here at Base Command Manager, you can gather information about the amount of namespaces, the amount of nodes, how many persistent volumes, PVCs, replica sets, replica controllers, services. You can see the pods that are running, that sort of thing, and you can really, from here you could export alerts and do all kind of stuff, but you could also have that done from Kubernetes, from Prometheus, Grafana, that sort of thing. But this gives you, you can make some settings. You can add users, remove users, change the name, change the labels, that sort of thing. So it gives you some simple management of adding users, removing users from the cluster, and really from the command line, you're able to deploy this Kubernetes cluster pretty seamlessly with a wizard, that CMSH, or the tool that Base Command Manager does provide to you as a piece of software to deploy Kubernetes. So without taking too much time, I wanted to show off Base Command Manager, why it's important, where it sits in your solutions architecture, how much time it may or may not save for you, what it could and does do for me today, and what it could do for me in the future. Functionalities that you can kind of drill down into and maybe dig a little deeper on if it's specific to something that you want to bring. But from my team standpoint, we really wanted to use this to quickly spin up a cluster, Kubernetes container orchestration cluster, to deploy models and leverage generative AI. So this is our take on it. We're a very small team, and we went into this effort with no expertise around this tool, and we've been able to figure it out. So I just want to say, if we were able to do it, I think that other people will be able to do it, and we're here to help. So thank you, and looking forward to doing more things like this. Thanks.